How would you illustrate the following graph using level or contour curves? Here, the idea of a contour curve is basically how would you illustrate a 3D graph of curves using two-dimensional graphing. And so if you have this particular image here, how could you convert that to a contour map? Contour maps could be based on several things. They could be based on the height, depth, and so you can change the coloring based on the height, or it could be based on temperature. Meteorologists use those type of contours when they study the temperature over a particular area. They may have a color scheme to denote whether the temperature is warm or cold, or it may even represent participation in some kind of location. So we use our mathematics to be able to illustrate these contours. You could probably take this particular image and convert it to something like this. You've probably seen these before. So we can use so-called level curves to illustrate so many things in terms of mapping. Now here, level curves are defined by taking the function z equal to f of x, y, and then setting z to be some number or parameter that we call c. As c changes, then we can see the various contours of the graph. So we take this problem. And so we have x plus y is equal to c. So if c is -1, then we get x plus y is equal to -1. If c is 0, we get x plus y is equal to 0. If c is equal to 2, we have x plus y is equal to 2. If c is equal to 4, x plus y is equal to 4. Now we can relate the functions in a different way to be able to graph. Y is equal to -x minus 1. Y is equal to -x. Y is equal to -x plus 2. And then for this one, y is equal to -x plus 4. So now we graph So if we graph the first one, this is a straight line with negative slope. Here the y-intercept is -1. Then the next one, negative slope again, the y-intercept is 0. I'm off. And then the next one, for c equal to 2, the y-intercept is 2. And the next one, the y-intercept is 4. And then we can label now. C equal to 4, C equal to 2, C equal to 0, C equal to -1. All right. Well, let's look at another one. Mm-hmm. Yes, sir. So for this one, we have x squared plus 4y squared is equal to c. So the c changes the values. We want to be able to depict what this is. This equation is what graph? Okay, it's an ellipse, right? Very good. The interesting thing, again, the level curves takes the 3D and maps them into the two-dimensional space. So we're just basically, we use x and y because that z becomes just a fixed number c, right? So this is just an ellipse. So when c is 0, we get x squared plus 4y squared equal to 0. That's only one point. That's at the origin. When c is 1, we have x squared plus 4y squared is equal to 1. When c is 2, x squared plus 4y squared is equal to 2. When c is 3, x squared plus 4y squared is equal to 3. And then when c is 4, x squared plus 4y squared is equal to 4. Now we do some work on each of those equations to be able to graph. This equation, to look at it, this is x squared over 1 squared plus y squared over 1/2 to be squared is equal to 1. That 1/2 downstairs to be squared is 1 over 4, right? And so y squared divided by 1 over 4 is still 4 times y squared. Are you with me? Now, why do I write it like that? Because we can identify a and b. I want to put this in the standard form for the ellipse equation, right? The ellipse equation is x squared over a squared plus y squared over b squared is equal to 1. Right? So that's what I have in mind for this so-called ellipse. I recall its equation. So I write each function now in that form so I can graph. Because if I know a squared, then I locate on the x-axis plus or minus a. If I know b squared, I locate on the y-axis plus or minus b. Just draw my ellipse. Right? So here you can identify that your a would be plus or minus 1, your b would be plus or minus 1/2. Right? Let's look at the next one. X squared plus 4y squared is equal to 2. First of all, for the ellipse equation, I need to have 1 on the right side, so I have to divide everything through by 2. So I get x squared over 2 plus 2y squared is equal to 1. This implies that I have x squared over the square root of 2 to be squared plus y squared over 1 over the square root of 2 to be squared is equal to 1. And you got to have a calculator to find the values of square root of 2, 1.4, something like that, but then that 1 over the square root of 2, you want to be able to find that on a calculator to get those points so we can graph that correctly. That next one, x squared plus 4y squared is equal to 3. Again, divide through by the 3. X squared over 3 plus 4y squared over 3 is equal to 1. And then I write that in the standard form. It's x squared over the square root of 3 to be squared plus y squared over 3 over 4, and that's the square root of that, to be squared is equal to 1. Then that last one, x squared plus 4y squared is equal to 4. Divide through by the 4. So I have x squared over 4, or just say 2 to be squared, plus y squared over 1 to be squared is equal to 1. So that's nice and smooth, right? And just plus or minus 2 for A, and then plus or minus 1 for B. So for the first point, the first graph, which is a point when c is equal to 0, just right here at the origin, no more calculators here. We can get this one. Here, x is plus or minus 1. So the x is plus or minus 1. And then the y is plus or minus 1/2. So that's the first one. And if you jump between this guy when c is equal to 1 to when c is equal to 4, I'm going to jump there because I can get those numbers. That's smooth. X for c equal to 4, x well, a is equal to plus or minus 2. X plus or minus 2. And then the y is plus or minus 1. Let's make it a different color. Try it one more time with my graphing skills. I'm doing my best. Now, you know the other two will be within there, so just graph that, those. No, don't move. Okay, don't know why it's moving. Let's see. Obviously, they're not touching, but based on my deformed hand, they're touching, but we get the idea, right? Yes, sir. Because I'm trying to write this in the form of x squared over a squared plus y squared over b squared. How would you get a and how would you get b? I took this guy, I took that 2, and I wrote it as the square root of 2 to be squared. Isn't the square root of 2 to be squared 2? But now I know that a is the square root of 2, right? And then b is 1 over the square root of 2. That's why. Yes, sir. Okay. Any other questions? Good. All right, let's look at this one. Here, this is c, so I have the square root of 9 minus x squared minus y squared is equal to c. Now I'm going to harm this just so that I can see what's happening with c. That is, I'm going to square both sides just to kind of see what's happening. 9 minus, but I remember that c is going to be positive. So this is 9 minus x squared minus y squared is equal to c squared. So that becomes x squared plus y squared is equal to 9 minus c squared. So now that's what I use. Oh, by the way, what is this? X squared plus y squared equal to a number. Circle. So c is 0. I get x squared plus y squared is equal to 3 squared, or 9. C is equal to 1. X squared plus y squared is equal to 9 minus 1, or 8, or 2 times the square root of 2 to be squared. Here I'm just identifying the radius. If C is 2, x squared plus y squared is equal to 9 minus 4, 5, or the square root of 5 to be squared. Then C is equal to 3, x squared plus y squared is equal to 9 minus 9, we get 0. And that's just 1 point at the origin. So we get the first one when C is equal to 0. We get a circle with radius 3. And then all the rest shrink from there. I don't know if I had circle graphs on that or not. Might be able to get that. That's not a circle. I don't have any circles there. Yeah. Just use the good old-fashioned hand rule. Hit one there. These two were perfect circles. I'm not doing so well on my graphing. Yeah, they're centered around the origin, right? Oh, man, I'm having a hard time. I need a handkerchief to wipe my forehead. But let's try this one more time. So we have one there. Okay. Let's move on. X times y is equal to c. Here we have y is equal to c over x. What graph does this depict? Rational function with x equals 0 is a vertical asymptote, right? So if c is equal to 1, you recall we have that. If c is equal to -1, and then for each number, we just keep refining that. And you get the idea. Any questions there? All right, you try that one.